The old days of rallying were great, cars with crazy power and no limit zone by the crowd. With modern rules, the same crowd is now watching from the sidelines. The golden age may be over, but the era stood in many hearts, including one fantastic game. The Art of Rally. Hi, I'm Domin and I will be recreating crowds from Art of Rally in Unity. For now, I created basic placeholder vehicle using scaled cube for body, and Unity built-in wheel colliders with torque and steer taken directly from input. Simply putting one on car would be not practical to use. For this, I created simple follower code that was setting camera root position and rotating child camera to look at car, so I could easily move relative camera position in editor. First, I had to determine how crowds work in Art of Rally. I assumed their behavior is made of few simple rules. Looking at the crowd, we can see that characters in crowd are staying in place unless affected. Characters in crowd are avoiding incoming car by moving sideways to its path and will get pushed away if about to get run over. And finally, characters are spreading in a way that prevents clipping. Assuming by default characters will stay in place, I can translate this behavior into just 4 rules. First, if character approaches car too close, it will be pushed away to save radius. Second, if 2 or more characters start touching, they will be pushed away. Third, characters will try to keep their original position in crowd. And fourth, characters will try to move away from path of approaching car. So I started by making very simple grey box character. Since I will be having a lot of them in crowd, I created script to spawn them at random in circle. Right now car cannot interact with them. I will therefore start with the first rule. For that, I will need to create collision detection by checking if character in crowd is closer to the car than specified collision radius. In that case, I'm moving character away by distance it penetrated into the radius. Now when going through crowd, the characters are correctly being pushed. Next, I added second rule. To keep characters from clipping into each other, I can check overlap distance between every character in crowd and with each other. If the distance is less than collision radius, then both characters will be pushed away with half of distance they penetrated into other's radius. Now going through crowd, it correctly is pushed away with no clipping. Currently, if character is moved, it stays there, which feels unnatural. It's time to add the third rule. To fix that, I added point of interest that's set to spawn position. Then each frame, system checks if character is in point of interest, and if not, moves it in time towards predefined position. Crowds will try to move back to positions they were before car displays them. In my opinion, it adds a lot of lifelike dynamic to it, and I think it's finally time to add final fourth rule. As fourth rule said, the crowd should disperse from path of car. To do that, I can take velocity of car as ray along which I can project sphere to check for bodies overlapping with it. For this, direction and distance to ray is taken, that can be used to move them away in time. Although our rules are now enforced, there's still a lot of to do. Let's tackle visuals next. Right now, crowd is completely grey. To color them procedurally, I created simple shader that changes color within character's height. By adding script table object with predefined colors, the crowd is finally vibrant. I also replaced car cube with proper car model and gave it red color to make it faster. Next, I tried adding more crowds to screen. Because I was using static reference in car controller to crowd, nothing was happening with new crowds. To make process automatic and avoid object discovery, I made crowd manager singleton that will return to car all crowds within its range. All crowds will be registered self within that manager on awake. While testing, I've run into issue. Because both crowds and manager initializes on awake and scripts execute in order, crowds are trying to register self to not yet initialize manager. Because I want both to still work on awake, I offsetted earlier default execution order in crowd manager. Now everything registers correctly. With that, I updated card to work with new crowd manager and multiple crowds are working correctly. With current implementation, I am only checking where car would move in straight line. To fix that, I am simply calculating difference velocity vector between frames and rotating prediction rate towards it. Driving around now results in much less casualties in crowd. Next I tackled optimization. Since I already know performance impact is caused by crowd, I will use frame rate as metric. Testing with single crowd, I easily determined that character count heavily impacts performance even when non-visually collided. That's because I'm checking all characters in crowd with each other. This check increases quadratically with crowd size. For example, 200 characters will result in 40,000 checks. To improve on this, I created a grid, through which I can assign characters. With that, instead of checking all characters, I can simply aggregate characters from neighboring grid cells. If done for every cell containing at least one character, this results in same behavior with much less performance impact, and is dependent primarily on character density in crowd and not only count. One more optimization I can easily implement is crowd cooling. To visualize active crowds, I made camera look down with orthographic frustum which describes what camera sees. As you can see, all crowds including ones out of view are updating Cozy game to run at only 14 frames per second. To check if crowd is visible, I can use camera frustum. It's composed of 6 planes which allow me to check for assigned distance. If any of these distances will be negative, that means point is outside of view. Since crowd is spread, I can just add it as a radius to distance check. Finally, I'm disabling only crowd update effectively refusing its behavior. Any render cooling is left up to the engine. With that change, average frame rate heavily improved. Let's tackle crowds still feeling lifeless. Right now characters are just staying still. I wanted them to feel alive even when nothing is interacting with them. Similar to original, I want characters to jump periodically. Each crowd has a chance for one character to jump each frame. When jump triggers, character graphics is moved with do-jump from .win package. That was enough to make everything feel a lot more lively. When looking at crowd, I did not really like the way that characters were distributed, so I fixed it next. Picking at random generated coordinates from my method of angle and distance, it has tendency to return more position near center of circle, which resembles Gaussian distribution. Instead, Fermat spiral can be used, which will return positions with equal density. It looks way better and resembles original, but still can be slightly randomized by adding minimal random position offset at the end, resulting in very natural distortion. Looking at crowd now without random offset, it already seems way better and allows me to place a lot more characters in same space. But with additional random offset, these few characters become convincing little crowd. As final touch to crowd, I got chilling sound. What is left is small track to see how it all looks. And there, we finally have it. While the result is not an exact replica of the original, like with many things, just trying to copy something does not result in getting the best value. So instead, I've created a system I wanted to feel alive, and I think I have achieved that. I also proved that just few simple rules were enough to create quite complicated looking behavior. Thank you for watching, and I hope you liked the video. I aim to create more videos like this, so consider leaving a like and subscribing. Till the next time. Bye!